Chapter 10.4 is about deferred annuities. And basically, a deferred annuity is basically just a complex, in other words, two-part or more part annuity problem. So we know that our formulas and our calculator works whenever the interest rate is constant, the amount of the payments are constant, there is no change to the capital, so there's no adding or subtracting from the PV or the FV, and the number of payments, or if we're comparing something, basically the N, but the N isn't really not going to change, but it's really the interest rate, the payments, and the capital, these are constant. What a deferred annuity is, if anything of these change, so if there's any change, but we don't have the answer yet, this makes a deferred annuity. Well, a deferred annuity is actually a really specific type of this, but it's where we have something where there is a time where there's no payments, and then there's a time when there's a bunch of payments. So it's a two-part problem. So we're not going to, nothing's really revolutionary except that if we're calculating a future value, we're going to take a calculation here until something changes. We're going to calculate that future value and we're going to turn it into a present value for the second half and do another problem. Also, if we're going the other way, we could say we're going to calculate, going back, we're going to calculate a present value, and we're going to turn that into a future value for the second half of the problem. So deferred annuity is basically solving something for one half, making some change in your calculator, and then solving the second half. So we also know that if we're going to change this from a future value to the present value, if I have a positive present value here and I go here, the future value is going to be negative. So every time I do this, I'm probably going to use the plus or minus button on the calculator to continue on with an annuity problem. So starting up, we're going to take a look at question 10 on page 407. So page 407, number 10. It says, using inheritance he recently received, Sam wants to purchase a deferred annuity that will pay $5,000 every 3 months between age 60, when he plans to retire, and age 65, when his permanent pension will begin. The first payment is to be 3 months after he reaches 60, and the last to be on his 65th birthday. Sam's current age is 50 and 6 months, and the invested funds will earn 6% compounded quarterly. What amount was he invested in the deferred annuity? Okay. So for this, we always start with a picture. In our deferred annuity picture, we're going to say, well, we have a starting time, and the starting time is going to be age 50 years and 6 months. And this amount of money is going to sit in the bank account until he gets to age 60. And this is going to go till age 65. And the first payment is going to be after the 60th birthday. So we have all these payments in here, and putting some money on it, he's going to get paid $5,000 every 3 months. So because he's getting paid, this is going to be positive $5,000. And we can invest the funds at 6% compounded quarterly, and we want to know how much he needs to invest. So this is 6% quarterly, and we want to know the amount here. Well, taking a look at it, we need to know either present value or future value. So we don't know what the present value is, so we better know what the future value is. And in this case, at age 65, this annuity is over, so there's going to be no money left. But we also don't know what this value is. But we do know that we're not going to make any payments in here, but we're going to collect all of the payments going back for 5 years. So it's going to be all these payments coming back. So let's do this as two problems. First problem A, then problem B. So for this problem, we're going to say, well, we have a future value, which is 0. We have payments which are going to be $5,000. We have an interest rate which is going to be 6%. We're going to compound 4 times a year. We're going to have payments 4 times a year. So that's going to be 6 over 4, which is equal to 1.5 as an I. So we can use either the method of 6, 4, and 4 or 1.5 as an I, but either way, now we're going to say, well, how long was that? Well, from 60 to 65, this is 5 years at 4 times a year, so there's going to be 20 payments. If we take a look at our calculator, I'm going to say I have a future value of 0 as a future value. We have $5,000 as a payment. We have 6% interest per year. That's going to be compounded 4 times a year and 4 payments a year. And we're going to do this for 20 payments. And we're going to compute our present value. So in order to do all of these payments, we're going to compute the present value to be negative 85, 843.19. So we're going to get $85,843.19. And just as a little cross check, how much we're going to get out of it? Well, we're going to get 20 times 5,000. We're going to get $100,000 out of it. So $85,000 plus interest over 5 years is going to be equal to $100,000. But now we have the second part of the problem. If we say, now that we've got this present value, we're going to take this all the way back here to figure out what that present value is going to be. So we have a second problem. And our second problem says, well, we have to know what our future value is. And our future value, this is going to be that value there. But we're going to do a plus or minus because here we said we had to invest $85,000 at this point, but as we're going to have to get the money out of the first annuity to go into the second annuity, so this has to change. So our future value is going to be $85,843.19. On my calculator, I'm just going to take this present value, I'm going to swap the sign, make it a positive value, I'm going to store that in my future value. So I've swapped the sign here. My payments for the first half of this annuity are now 0, so I'm not going to do any payments. The interest rate doesn't change, so I don't have to touch it, but we can do it the same way. And the end, it is going to change. The end is going to be, well, from 50 to 60, this would be 10 years, but since we're halfway through, this is 9.5 years at 4 times a year. Okay? So 9.5 times 4, there's going to be 38 payments, or 38 periods. Put that as an N. 0 for the payment. Now I'm going to compute the present value, and this is going to be negative $48,752.43. So when we need to invest, $48,752.43 on halfway through the 50th year, so that by the time we get to age 60, we have $85,000 in the bank, and then we can withdraw $5,000 quarterly payments until age 65, and in the end, we'll have $0.